I'm glad that is the case. Okay. All right, so this section, everybody with me? This section starts off with the mean value theorem. Okay. The mean value theorem is going to state that if f is continuous on the closed interval a, b, and differentiable on the open interval a to b, then there exists a number c in a, b such that f prime of c equals f of b minus f of a over b minus a. Okay, so let's kind of draw out a picture for what that means. This is similar to intermediate value theorem and is going to be sometimes easy to confuse with intermediate value theorem. It is different. Just to recap intermediate value theorem. Intermediate value theorem tells me that if I go from like here to here and I have a, like let's say that is 2 and this is 10, and I want to know, does my function ever equal 5, right? So if I have a continuous function, then I have to, if I have a continuous function, then I've got to cross 5 at least one time to get there, right? So I would be able to say, yes, definitely it equals 5. Intermediate value theorem deals with function values. So it would be like proving that f of x has to equal 7 at some point. Mean value theorem is going to be similar, but it's going to deal with derivative values, not with function values. So the intermediate value theorem, if we kind of draw ourselves out a graph here, and here is our x-axis, and here is our f of x axis, then I'm going to put here on my x-axis a point A and a point B over here. And we have some function that is both continuous on the closed interval and differentiable on the open interval. It just means it doesn't have to be differentiable at the endpoints. Usually that does not end up being something that you have to distinguish there. So I could have, you know, whatever here. So what the mean value theorem tells us is that whatever our function is, so like right here, this point right here would be at A, so we would label this, that would be f of A right there. And I could even label this point A, f of A. And then my other point here, actually let me change my graph just a little bit so it's easier to label. A and B are too close together. Let's do that. So B would be right here. So over here we would call this f of B. And I could even label that point right there, B, f of B. So what is f of B minus f of A over B minus A? What is that telling us about this graph? It is a slope, and it's the slope between A f of A and B f of B, right? So like this right here, this is our slope of this line between the endpoints. Right. Because your f of B and your f of A, those are y coordinates, because like you would plug in the number and then you would get the y coordinate with it. And sometimes we will have y coordinates that we're using right there. So the slope between the endpoints, we could even label this slope between the endpoints, has to equal f prime of c, which is the derivative at some point. So what it's telling us here is that somewhere in here we've got to have a derivative that is equal to that slope between the endpoints. I would say probably for this it might be like somewhere around here. That slope of that tangent line right there looks about parallel to that. So in this case, if that was the case right here, that would be our C value. So the mean value theorem tells us that at some point the derivative must equal the slope between the endpoints. So, this next example is my favorite example for us to help us remember this, because it definitely is like something you can actually think about. It also has caused great debate over this. So, I've been using this one for a long time because these are names of kids I had like the second year I taught calculus. So, Officer Nance.
Is it Ryan Nance?
No, it is Connor Nance, which is...
I'm pretty sure Ryan Nance.
No, definitely not. But is Connor? I think Connor is his brother or cousin, but Trevor is their cousin. I think Connor is their brother. They're twins, right? Yeah, there's Alex and Ryan, right? Yeah. I think Connor is their older brother, and Connor is still one of the top kids I've ever had in calculus. So super smart. He was super smart. So
yeah, Alex.
Yeah.
They're definitely not alike at all. They're like very
so anyway, Officer Nance and Officer Shoemaker. That's Madison Shoemaker, who is, I believe.
Is she one of the calculus people?
She is. Is he male? I think she is the last person we had to get the Moorhead scholarship. Unless there was somebody between. Oh, Chandler. Yeah, Chandler got it and took the gap year option there. But there's no difference. She still got it. So yeah, you're right. Chandler did get it. This was the last person before Chandler, and it's been like 15 or 20 years since we had a Moorhead scholar. Whenever she got it. So anyway, very high remarks, both of these students. All right, so, yeah. All right, so, Officer Nance and Officer Shoemaker are both waiting on the side of I-77 for speeders. They are 6 miles apart, and the speed limit on the entire stretch of road they are covering is 70 miles per hour. They are exactly 6 miles apart, and they can prove it. Officer Shoemaker sees a brand new Corvette pass her going 65 miles per hour. She calls Officer Nance to tell him to be on the lookout for the Corvette and gives him the tag numbers. Exactly 4 minutes later, the Corvette passes Officer Nance going 65 miles per hour. Officer Nance turns on his lights and pulls the Corvette over for speeding. What? Is he justified? What speed should he write the ticket for?
Is the Corvette going 65?
Oh.
Yes.
4 minutes, but like.
So, I need you, on your own, to figure out if Officer Nance is justified and what speed he should write the ticket for.
Who knows if it's the same Corvette or not?
It's tag number. They've got tag numbers.
Okay.
They have tag numbers. They can prove they are exactly 6 miles apart, and they can prove it was exactly 4 minutes. Let's assume they have all of this proof. All right. All right. I need to know, is he justified and what they should write the speed for. Also, keep in mind that's 4 minutes, not 4 hours, so you're going to have to do a little conversion. 70. Yeah.
Yeah.
So, it is 90 miles an hour. It is the average speed. So, somebody that got 90, tell me how you got 90. All right, so you said he went like 3 miles over in 2 minutes. And then what'd you do? Okay, so like you multiply it by, so you got 60 minutes. 1 hour is essentially what you're doing if you're doing like stoichiometry. And then 3 halves times 60, you're going to get 180 miles divided by 2 hours, which is 90 miles per hour. You could do the same thing there with 6 miles over 4 minutes would work as well. You could do that. What did you guys do?
We did like 6 over 4, and then and 4 is 1/15 of an hour, so we did 6 over 1/15, and then you dividing factor is easy as 5. 6 times 15 is 90.
That works. So you can just go ahead and change your minutes to hours and then divide. That will work. Anybody do it differently? This is why this is usually causes great debate. All right, so if they have solid evidence of this, right? So like if they have solid evidence of everything, now in practice, I doubt this is happening.
Math don't lie, though.
In practice, I doubt this is happening. I don't think they are setting you up on the side of the highway like this. Although I will say, if you ever go, whenever we do drive to the beach at Thanksgiving, there in High Point always, every year on the, we usually go down on Wednesday before Thanksgiving. Every year they have some big ticket campaign, and they have like a motorcycle cop a lot of times up on a bridge, and he is just like radaring everybody, and there's like cops up and down, but there's like 15. And there are people pulled over left and right the whole time, and they're just like getting everybody. But I don't think they're doing this. They're just like radar gunning everybody. But, yeah. So if you ever have to drive through High Point the day before Thanksgiving, like last several years I've done it, it's always the same. And my dad always calls me and says, "There's tons of cops out at High Point. Make sure you slow down." And I always say, "I remember, Dad." So, this is mean value theorem. Because what are they finding whenever they use the radar gun? As far as exact speed as that moment, as far as calculus goes, what is that? It is the slope of the tangent line, instantaneous rate of change, right? So what we're seeing here is that the car was going 65 miles per hour whenever it passed the first cop. It was also going 65 miles an hour when it passed the second cop. So, like what we're seeing here, like if this is at 0 and this is at our, how far was it? 4 minutes. And we got 6 miles right here. So, whenever it passes, this is distance here. We're doing distance, not speed that I'm graphing here. So, this is time, and this is distance. So, that car definitely, without a doubt, went from here, 0 miles from the first cop, to this point over here, 6 miles from the first cop, and it took him 4 minutes. So this car was not going as fast here. As soon as he got out of sight of the cops, he obviously sped up a lot, but then slowed back down. Now, this might be over-exaggerated, right? So what we know by the mean value theorem, because we would assume that this graph, by the laws of physics, has to be continuous and differentiable. Unless he can teleport from one place to the other, it has to be continuous, right? He cannot be 2 miles away and then suddenly 3 miles away instantaneously. That can't happen. You can't have a jump in this graph. It has to be continuous. It is also true that it cannot be, it also must be differentiable. Now, what we know about driving a car, you can slam on your brakes really hard, right? And you will stop really fast, but it still would, be not instantaneous. You're not going to have like a sharp turn. You cannot go from 20 miles an hour to 30 miles an hour in a moment's notice. If you have a fast car, you might can do it really quickly. But it cannot be at a moment, right? You cannot go. So we would know, knowing what we know about cars, this must be continuous. It must be differentiable. Unless we're breaking the laws of physics, it must be continuous. It must be differentiable. So we found that the average rate of change, the slope of that line right there, is 90 miles an hour, right? So the mean value theorem tells us there has to be at least one point where this guy was going 90 miles an hour, right? In this case, we actually can make the argument because we know it was 65 right here, and it was 65 right here. There would have to be two places that he was going 90 miles an hour. 90 miles an hour was not his top speed because since he was not going 90 miles an hour at the end points, he had to be going faster than that. Yeah, his average is 90. So we know at some points, like maybe around here and around here, this is a guess, this is not a precise graph, obviously, he was going 90 miles an hour. How fast was he going right here? Right here, he was going faster than that. He had to go faster than 90 degrees. Now, we can't prove what that speed was, so mathematically, I would write the ticket for 90 miles an hour. He went faster than 90 miles an hour without a doubt because he could not be going 65 at the end points if he had not gone faster than 90 in the middle. But minimum speed that he was going was 90 miles an hour. So if I was Officer Nance, I would write the ticket for 90 miles an hour. And I think that if you could prove all of these facts for sure, this should hold up in a court of law and this person should have to pay their ticket. Now, I don't think that cops do this in practice, but I think that it would be justified if they did. Question is, here's the question for you. In the digital surveillance world that we live in, can you put things in on the road that catch people doing like this? They got the red light cameras sometimes.
Like express lane things, like when you go through them, if you're in the express lane and get your tag and you get to the next lane at a certain amount of time, I feel like they could get you with that.
Yeah, like could they, like I don't think they do that for express lanes. Like they're just using that to charge you. But right, but could we end up in a world where, now I don't think you're going to see actual people on the side of the road doing this, but could we end up in a world where there's speed checkpoints and this is happening? Don't know. It's technology could definitely do this. I think one of your big problems is who's driving the car. But photo recognition and stuff like that, I don't know. Then tinted windows become an issue. Like, I don't know. I don't know. I don't think we're going in that direction. But yeah. So this is mean value theorem, though. The cop theoretically could write you a ticket for 90 miles an hour because of the mean value theorem here. The average rate of change, which is that slope between the endpoints, has to equal the derivative at some point. And that derivative is your instantaneous rate of change, your radar gun change. All right, so I've spent a lot of time on that. Let's look at the types of problems that you will see. So let's look at just a naked problem that is not got any context to it. So it says, given the function f of x equals x minus 3 squared on the interval from 0 to 4, find the c value that satisfies the mean value theorem. So they're telling us to find the c value that satisfies the mean value theorem, so we know that this mean value theorem would apply. This is just a quadratic. Quadratics are continuous and differentiable. It's not asking us to prove a mean value theorem here, so we don't necessarily have to state that, but it would apply. So what we're looking at for this here, in fact, let's graph it on Desmos just to get a picture of what's happening. That'll be better than if I hand draw this. So what we are looking at here is our function f of x equals, was it x minus 3 squared? Okay, and we are looking from 0 to 4 here. So we are looking at these 2 points right here. We are looking for the value that would make this true. So mean value theorem tells us that the slope between the endpoints must equal the derivative at some point. So for this, you need that average rate of change, that mean value, that average rate of change, which is the slope between your endpoints. Your endpoints are at 0 and 4, so you're going to do f of 0, which will be 0 minus 3 squared, which is negative 3 squared, which is 9. So we have the point 0, 9 is one of our endpoints. And we will find f of 4, which is 4 minus 3 squared, which is just 1 squared, which is 1. So I have the point 4, 1. So our average rate of change of f on 0 to 4 would just be the slope between those 2 points. So we would do 1 minus 9 over 4 minus 0, which will give us negative 8 over 4, which is negative 2. Now, mean value theorem tells us there has to be a place somewhere where the derivative equals negative 2, because our slope between the endpoints there, let's see if I can, that would be y equals negative 2 times x minus 4 plus 1. There's our slope, our line that represents our slope between the endpoints. What it's telling us is our derivative somewhere has to have a slope of negative 2 also. So, let's see if this will work. Okay, so what I've made here is a tangent line that moves with the graph. So if I'm trying to just here look at this, guess right there looks like where it is at, right? That looks about like those two tangent lines would be, the tangent line would be parallel to the average rate of change line. But we need to be able to find that algebraically as well. So, mean value theorem tells me derivative equals average rate of change. So to do this, what do I need to find? I already found average rate of change. What do I need? I need the point where the slope is -2. And what do I do to find the slope? Yeah, we'll do -2 equals, not x minus 3 squared, because that's the equation of the function. I need it to equal the derivative for this. So I would find the derivative. So f prime of x, you must use chain rule on this, although it's a very simple chain rule. You have 2x minus 3 to the first power multiplied by the derivative of x minus 3, which is just 1. So it's really just 2x minus 6. If you distribute there, you don't have to. It'll be a little easier to solve if you distribute, but not much. So that is our f prime of x. And we know that somewhere the derivative has to equal the average rate of change. That derivative is your radar gun speed, right? That is your instantaneous rate of change. It has to equal your average rate of change, which is your average speed for that time. So we would say 2x minus 6 has to equal -2. And now this should be a very simple equation to solve. We're just going to add 6 to both sides. 2x equals 4. Divide by 2. X equals 2. So they say C, so we could call it C. The C value that makes the mean value theorem true is at 2. That looks like about what's right here on the graph. Okay, so mean value theorem is average rate of change equals the derivative. And average rate of change is that slope between your endpoints. Okay, so here is an example where they might not tell you it's mean value theorem. In fact, a lot of times this is what the questions look like. They do not say mean value theorem in the question. It says, given f of x equals 5 minus 4 over x, find all values of c in the open interval from 1 to 4 such that f prime of c equals f of 4 minus f of 1 over 4 minus 1. So, this right here, f of 4 minus f of 1 over 4 minus 1, that is our slope between endpoints. Or our, I'm going to do average rate of change, AROC, average rate of change. This is our derivative, which is our instantaneous rate of change. Don't use that AROC and IROC. Don't use those like on a free response question, because that's not going to be accepted. Instantaneous rate of change, average rate of change. I just don't have room to write it out. So we need our derivative to equal the slope between the endpoints. So this function is f of x equals 5 minus 4 over x. So let's do our slope first. If I do f of 1, I'll have 5 minus 4 over 1. That is going to give me 1. So that's the point 1, 1. And if I do f of 4, I get 5 minus 4 over 4, which is 5 minus 1, which gives me 4. So I've got the point 4, 4. So my average rate of change would be 4 minus 1 over 4 minus 1, which is just going to give me an average rate of change of 1. So for your average rate of change, you just need to find those coordinate points by plugging in those numbers, and then use slope formula to find those. We need a derivative of this also, because the derivative has to equal that average rate of change. What would you guys do to find that derivative? You can use quotient rule. There's an easier way. I would do this. I would make this 4x to the negative 1. If you do that, you don't have to do quotient rule. There, so that x is in the bottom of a fraction, so we can write it with x to the negative 1. So if we take the derivative of this, what is the derivative of 5? 0. It's gone. Then we got to use power rule here. So negative 4 times negative 1 gives me a positive 4, x to the negative 2 power, which is going to be easier if we write it like this, 4 over x squared. Next step will be easier if we write it that way. Okay, so I've just found my derivative, and over here, 1 was my average rate of change on this interval. The mean value theorem tells me those have to be equal to each other at least once on that interval. So I would say 4 over x squared equals 1. How do I solve that? Multiply by x squared. You can't solve for something while it's in the bottom. So let's get that x squared out of the bottom. We got 4 equals x squared. What would we do next? Square root both sides. Here, that is going to give you plus or minus 2. However, would we use both of those answers here for this problem? We would not, because we're only looking between 1 and 4. So we would just choose our, did it say C up here? Yes, C. Our C would just be positive 2 here. If the interval included both, like if it was from negative 4 up to 4, then we would include 2. Oh wait, let's see. Hold on. Okay. Is this continuous and differentiable from 1 to 4? Yeah. It is. Is it continuous and differentiable from negative 4 to 4? It is not, because what value would make this not continuous? 0. So if your interval included 0, then you wouldn't be able to do this problem here. The way this is worded, I don't think you have to state continuity and differentiability, because it's asking you to find that value. You're going to need to state continuity and differentiability if they say that you have to, yeah, if it's worded like number 4. That, because 0 would give you a 0 in the denominator on that original function there, so you have vertical asymptote at 0. So mean value theorem would not apply if it was an interval that included 0, and then we wouldn't be able to answer the question. So, yeah, if you see something like that, it should be worded differently. Instead of saying, find this value, it should say, is there a value? And then you would say, or it would probably not even say that. It would probably say, like, can it be proven that there is a value? And you would say no, because the mean value theorem does not apply in that case. So it would probably be worded differently if it included 0 there. Okay, so the table below shows certain values for f, a continuous function. I think I need to change I think that has to be differentiable. Yeah, it does. That has to be differentiable. It cannot be continuous or we can't do the problem. That is my fault. Alright, so Table below shows certain values for f, a differentiable function. Is there an x value on the interval from 0 to 10 such that f prime of x equals 1/2? So, whenever you see this, this feels like intermediate value theorem. Because it's asking you, it's like asking you to prove there's something on this interval that equals this value. It feels like intermediate value theorem, and the way we're going to do it is similar to intermediate value theorem. What lets us know that it is not intermediate value theorem is we're talking about f prime, not f of x. If this said f of x equals 1/2, then you would do intermediate value theorem, and you would say because this goes from 5 to -2 that it has to cross 1/2 at some point. But it's talking about f prime, which tells us it needs to be mean value theorem. And for mean value theorem, you have to have a function that is continuous and differentiable. They've already told us that it is differentiable. You do still need to state that it's continuous. The way that you need to do this every time, if it told you that it's differentiable, so it doesn't matter if it's intermediate value theorem or mean value theorem, you must also say it's continuous. So you would say because f is differentiable, it is also continuous. I almost hesitated there because I tell you guys not to write it. I can take it right here as long as you call it f. Don't say because it is differentiable, it is also continuous. You can't. That it right there needs to be very clearly be referring back to. In fact, it's not going to hurt. It sounds weird to say, but because f is differentiable, it's probably safest just to do this. F is also continuous. Just don't ever, like, almost pretty much should never write it on your paper. I think it would be fine in this scenario as long as you've already called it f, but it might be safest just to not, like, never let yourself write it on your paper. All right, so this is how you always need to say it. Do not just say f is differentiable and continuous, because it did not tell you f is continuous. Unless they told you f is continuous above, you can't just say f is differentiable and continuous. You need to say because f is differentiable, because that's the information they gave you, f is also continuous. See the slight difference there in those two. So now that we have shown this is the case, mean value theorem should apply. So we are going to take our average rate of change on now it could be on any interval, but they tell us it's from 0 to 10, so that's what you want to check first. Average rate of change on 0 less than or equal to x less than or equal to 10. Now, to do this, we just have to do slope formula. So you got the point here, this is the point 0, 5, and this is the point 10, 10. So you're going to do 10 minus 5 over 10 minus 0, and that is going to give you 5 over 10, which equals 1/2. And then you would say by the mean value theorem. And basically you're just going to restate what the question was asking you, because here we just found the average rate of change was 1/2, so the derivative has to be 1/2 somewhere on that interval, right? So you would just restate. Instead of saying is there, you're going to say there is an x value on the interval 0 less than or equal to x less than or equal to 10 such that f prime of x equals 1/2. So there's other ways you could word that, but don't overcomplicate it. All I did here is they're asking, is there this point? And I'm saying, yes, there is what you were asking for. Just copy all that other stuff down, right? That way you don't have to really think about what you're saying exactly so much there. Okay, questions on that? All right, so function f is graphed below. What is the average rate of change of f on the interval from 1 to 5? Now, you could do some work, but they gave you the graph. What is your average rate of change from 1 to 5? 0. Because that line between those two would just be horizontal, right? And the slope of that line is 0. So you could do work if you wanted, but it's just 0. So it says, then how many times on the interval from 1 to 5 does the average rate of change of f equal the instantaneous rate of change of f? That's asking mean value theorem, because average rate of change equal to instantaneous rate of change is mean value theorem. But it doesn't say mean value theorem. How many times does that happen? 3. Where does that happen at? Good. All of your horizontal tangents will happen at maximum and minimum points, right? So right here, and right here. It doesn't ask where. It just asks how many times. So you would just say 3. Okay, questions on that? You'll see a lot of these that don't have work to them. They're just logic. This also has a special name for that theorem right there. It is, I think it is Rolle's theorem, but I might need to go look that up. Rolle's theorem is a specific example of mean value theorem, but you don't necessarily have to, like, know it. It can just be covered by the mean value theorem. So, for that. So, that's it, right? Your assignment, see, it's on Canvas. Let's go look there. I think, or was it a worksheet? I can't even remember. We shall see. We shall see. Yes, it's a worksheet. I've got it. I copied it. I'm on top of things. I just can't